Good afternoon, everyone. Okay, so we
Good
will start the today's
afternoon,
session
sir.
from here. It is already 3:08, so we can start right now. Okay, let me start. And those who are joined later, they will resume from there only. Okay, so I will start from here. Okay, very good afternoon, everyone. My name is Sumit Kumar. I am PhD research scholar at IIT ISM Dhanbad. We are in the week 5 of this coursework, which named is Geotechnical Engineering 2, and it is taught by Professor DN Singh sir from the IIT Bombay. And this is the second time when I am taking the lectures of the NPTELs as a TA for resolving the any issue which you are going through during the coursework. In addition to that, I am taking also taking the questions which may help you during your final evaluation or in the assignment as well. And along with that, those who have any doubt, they can ask the question over there. I try to solve it out. Okay, so from here I will start the today's session. Before starting that, I will add on some of the instruction. Like this coursework is going to be taken place for the 12 weeks, and it's maybe possible that one additional week I can also take, in which I revise the entire syllabus in a 2 hour class. And apart from that, one more point is that this class is going online at any point of time due to any network problem or anything else. If the connection get disconnected, please be remain in the meeting. I will rejoin and take the class from there. The chances of that is very less, but if it takes place, be patient and remain in the meeting. I will start from there and complete the class for you. Okay, and the content, the coursework, whatever the content PPT presentations which I am showing over here, I will also share it. We share these with you for your reference. Apart from that, these videos which I am presenting right now, those who are not here, I have seen that some new people joined over here during this class only. So those who have missed the last 4 classes, they can go through those video on the YouTube's. I uploaded the videos on the YouTube as well, and the link will be shared with you by the NPTEL team itself. Apart from the presentation file which we upload in the Google Drive folder, is also shared with you by the NPTEL team. Okay, so that's thing I want to make you aware, because I have seen that some new people are here which are not there during the previous classes. That's why I considerably add the points. And for those who are going to watch in the YouTube, this point is also very important. Okay, so let me start with the coursework for the today. So first of all, in the first 5 minutes, as we always do, recap of the last lecture we take, and then going forward, we take the new content. Okay, so let me start. So this is coursework named Geotechnical Engineering 2. And till the last 4 week, we have understand the different points of the shear strength, Mohr circle, how the Mohr circle works, how the different tests are performed. So in the previous class as well, we have started with the definition. Afterwards, we moved that the factor that affect the shearing criteria in one way or the other. We also consider, I request everyone to please keep your mic off, because it will create the disturbance during the class. And if you have any question, I will give you time. You can also type in the chat box. I will try to resolve, because after 1 hour we will take the 5 minute break. So over there I can go through those things and I can resolve those problems. So I will request everyone to keep their mic off. If any problem related to sound or presentation is not visible, you can tell me at any point of time. That's not the problem. But as I am aware, I also joined from the another source as well to keep look at that whether my presentation is going smoothly or not. So I have seen there is no problem. But if any problem for anyone, they can stop me at any point of time, and I will try to resolve the issue regarding any the audio or the presentation thing. Okay. See. Okay. So see, we have understand the applications and significance. Why we have important the shear strength. We understood the Mohr Coulomb failure criteria and what's its important, how it started, what is the present considerations, how the data are taken place, how the Mohr column failure well are formed. We have taken the example over there. We vary the first of all we concern with a sigma 3 value, and afterward the deviating stress is applied and how the variation takes place. Those things discussed with the help of this graph as well. Apart from that, this thing what I have said earlier will be discussed over here. And these presentation are there with you. Those who are not there, if you are go through the video or the presentation, you will understand everything. Okay, sorry, some question is there. Let me see. Okay, sure. I will provide the complete solution. That's not the problem. And today you will see assignment 2, 3, 4 directly sent answer to. Oh, so that's not the thing. Basically, the whatever the assignment has been given to you this time, no, that is not allowed to be solved during the class. Yeah, you can ask like the what is the deadline to submit the assignment for? Anyone can reply? Viratna Sri, can you reply that what is the deadline? Okay, already submitted. So that's not the problem. Okay, I will try to give the solutions for that also. But whatever the instructions we have, that we are not keen to provide the solution of the assignment which are going during these times. And for this coursework, there is no previous assignment what I have access to. I make the my own questions which you see we are going to solve today as well. But so as per instruction, we could not go with that. But yeah, specific some problems are there in the assignment 2, 3, 4. You can ask me over here, and I will provide you. You can type the question as well, and I will try to answer those questions. And and or maybe in the subsequent class, I try to give the answer of the some of the problem. Basically, I have also not gone through the assignment 2, 3, 4 questions as of now, so I'm not aware about that as well. Okay. So, what are the problems? You can type over here, and I will try to answer in this class as well. Or in the subsequent class, I definitely try to answer what are the assignment problems. I will go through them. Okay. And I will try to solve the question and provide some questions which will help you in solving those problems which I have given in the assignment 2, 3, 4. And that will be helpful. Okay. No problem. Yes, right. Okay, so we are talking about what we have gone through during the previous session, so that a quick revision. So we will move ahead with the new content. Okay, so we have gone across about the Mohr-Coulomb failure criteria. We understand that how the Mohr-Coulomb failure criteria takes place. We understand the triaxial test, the three types of test which we perform during the triaxial test is like UU test, CU test, and CD test. We have gone across that. We understand that how the how these tests affect what are the conditions, what are the drainage conditions in which test the volume remain constant and how volume get changed. We also understand that if we consider the effective stress criteria and the total stress criteria, the value of C and phi and C dash and phi dash, how it change for the different test. We are also understand the equipment size which normally used like the length to dia ratio or so those things we have understand. We have seen the schematic diagram. We see the test procedure. So I am not going to discuss it today because we have already discussed. I'm just giving a quick recap so that the things which we have gone through during the previous class will be in your mind. Okay, so we have understood those things. Setups. What are the setups? What is the first stage? Like the consolidation stage. Second stage is the debating stage. In the consolidation stage, the pressure is applied with the help of water. First of all, how sample is prepared. Everything is discussed during the previous class, and these are the schematic diagram which has discussed during the last class in very detail. We have understand the tri-axle testings, what are the purpose, CDCU, UU, and usage tests. All things are we have gone across. These are the definitions, and this presentation is already shared with you, so you can go across that. That's not the problem. Okay, and we have understand the pore water pressure measurement, analysis parameters, what are like the cohesion and angle of internal friction. That is, we have understand some of the important formula which I usually say like remember that sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2 c tan 45 plus 5 by 2. So what is the sigma 3? Sigma 3 is the stress during the confining stage. Sigma 1 minus sigma 3, that is equal to sigma d, that is the deviating stress which is applied during the deviating second stage, basically what we call. Okay, so those things we have discussed. We understand the significance of triaxial test, that how you implement the physical condition during the field. As you are aware, some of new people are there, so I will again explain that how the physical significance is tested. That's not the problem. Some points are also covered during this lecture. Some points are there. We are going to discuss those things about a triaxial test before moving to the problem. So that's not the issue, but I will suggest you see. We have understand the triaxial test, and in triaxial test we see that it signifies the real field condition in a laboratory in a way. How? Because consider you must consider there is a table in your room, and you consider that it is a soil mass from ground to height of the table is a soil mass. So if you consider a specific section from 10 cm or 20 cm, for example, 10 cm below the table section, if you consider a soil section, a spherical, cylindrical soil section, and you see, if you assume there is a cylindrical soil section, then you can simply see that assume, okay, this pen is not visible. Okay, no problem. If you see a specifically a cylindrical section is there, then on that section the stress is applied by the adjacent soil mass only, and that stress is applied in the laboratory with the help of water in the triaxial test. And as the some building blocks or some any constructions work is going on over the soil mass, so some stress from the upside is also applied, that is actually applying in the physical condition as well. So it simplifies the practical implementation of the soil condition in the field to the laboratory in one way or the other. Okay, we will discuss. We have discussed several times earlier as well, and we will discuss again and again till we are in the shear strength. Afterwards, when we move to the earth pressure, we will move to the new condition. Okay, so we understand the significance, and the significance is over there. We also understand the advanced insights in the triaxial testing techniques. Over there, we have understood the mercury column era, in modern era, what we are doing, how the load frames and plunger and probing things came. We earlier the mercury things are there. So as the technology advancement, the calculations are more precise, and result which we obtain is very close what is actually in the field. So that's we have understand. We also understand correction factor. What is the importance of correction factor? Why correction factor is needed? Like the radial drainage consideration, and different approach we have understood. We have understood U test, CD test over there. As you see this image, here the intercept on the toe axis is the cohesion, and the angle with the horizontal axis is the angle of internal friction. We have understand that how you can see sigma 3 and sigma 1 minus sigma 3 is always constant for the test 1, test 2, test 3, and why that is not the case when we perform another test. And this is the total stress approach. When we go to the effective stress approach, C dash 5 dash for the all the tests which could be performed in a specific type of soil is same. We understand that U test, what we consider like in U test unconsolidated and trained test during the both stage, like the stage 1 and stage 2, like the consolidation stage and the deviating stress. In both the stress, the stress which is applied is always the drainage is not allowed, the water is not allowed to flow out, so the volume remains constant. Those things we have understood, and we understood to the CUCD test how the Moore failure envelope is formed, and what is CCU equal to CCD, whether it is equal or not, why not equal. So those things we have understood during our previous lectures. Okay, so up to this I will leave the previous session division. Now I will start with the new content. I think so all the peoples who are likely to join are over here. So we can go with the new contents. Okay. See, Okay, I think so. My slide is visible. Yes. See. So we will start with the interpretation of the triaxial testing result in the geotechnical engineering. When the results come, its application in the geotechnical engineering very much important. As we have gone through in the previous lecture, we understand that the stresses, the in triaxial stresses, the cohesion and angle of internal friction. When we talk about the shear strength, these two criteria, because the basic relation when we say C plus sigma and tan phi is the value of shear strength. So the two important factors is the cohesion and angle of internal friction is a most important thing which come in our mind before stating that this much the shear strength this soil section have. So those things is carry forward with the help of these tests. As we have understood all the tests we have from the in the previous four class, what we have understood, we have also understood the direct shear test, which is also called box test, and vein shear test. In the third lecture, as you aware that we have gone through the vein shear test. Over there, we have understood that how the application, as we say that the vein shear test is applied on the relatively soft soil, because if the soil is very hard and the torque could not be applied, and the value of T by pi d square, the relation which we say, um, okay, sorry. And the relation which we say like T by pi d square into h by 2 plus t by 6 is not applicable. So those problems are over there. But when we are going over here, in the triaxial test, it simplifies the real field condition. In the direct shear test, what is the problem? What is the limitation? You must be aware that in the triaxial test, the failure plane is predefined. We already know that the failure takes place from this section only. So that is the relation. Over there also, we could not control the drainage. So many problems are there. But in the triaxial test, all the limitation gets eliminated. So that's the thing. See, okay. So we will move ahead and we will see in this presentation, in this today lecture, we will going across. We will discuss the interpretation of the triaxial test result in the field of the geotechnical engineering. Triaxial testing is commonly used to assess the properties and the behavior of soil sample. Exactly. And the results are often from these tests can provide valuable insight into the characteristics of the soil and suitability of the various construction project, right? Because I have seen from the very first class, in the very first class, when we are not aware about these facts, that what is these things, I have said very much clearly that when we are performing these, when we are getting to gain the knowledge in this direction, see, we should be aware that why we are, first of all, I always say that always ask the three questions whenever you are studying anything. The questions are that uh, why it is important, why we are reading. So why shear strength is so much important. As shear strength is important in the all type of projects. Before construction of any superstructure things or any infrastructure project, any building, any road, any railway structure, we needed to understand that how much load the soil could bear before designing any foundation or anything. So that's why the shear strength is the most of the important criteria. As what the problem? Okay, give me a minute. Give me a minute. I will sort some problem over here. Give me a minute. I'm writing a mail in the chat box. Please send the question on the mail ID, and I will try to solve it today itself. And if not possible, in the next class, definitely. I am saying it to everyone that please send the question on this mail ID, and I will try to answer the problem. Okay, I have written a mail in the chat box, and I also pinned that mail. So please send me a mail on this email ID, that is smitkumar06272 at the rate of gmail.com, and please send me the whether the screenshot or the whatever the PDF, I don't know. Please send the question on this mail ID, whether I will solve it today itself or definitely in the next class. So please share all the assignments and what are the specific problem. Please specify the specific problems in your mail ID, so that I will not, if the instruction is there that I could not solve the entire assignment problem of this session. So I will solve a specific problem which you are facing the problem, and share the entire problem questions. I will try to make my presentation as well, question as well regarding the same. So that will be helpful for you. Okay. So those who have problem, I have written a mail ID in the chat box. Please send me a mail. Send the question on those mail. Okay, I think so. I'm clear. Okay, so I will move ahead. We are going very slow. It's already 3:32. Okay, so we are. Now I will speed up my section because I have to solve at least 13 to 14 problems as well during this class only. Okay, so the purpose of triaxial test. So triaxial test is primarily conducted to identify any issue or in the with the soil, as well as to validate the effectiveness and compactness effort. By measuring the pore water pressure during the underground testing, engineer can gain a better understanding of the soil response and behavior under the different stress conditions. As this information is very crucial for understanding and developing an approach for the any construction work which are going to take place. So when we going to interpreting pore water pressure, as I am have said in the very second class only, that the water is the biggest enemy of the soil. If the water is not there, there is water table is far below the ground, far below the ground surface. So there is a 90% of the problem get eradicated, because as you are aware, as you have gone through, maybe gone through the geotechnical engineering one at some point of time, you understand over there when you are going through the chapter of the second chapter itself, in which you have understand the total stress, effective stress, pore water pressure. So over there you understand that as the water table get rises, in any condition water table get rises, the effective stress value get decreases. As initially you have understand, we see that CL strength equal to C plus sigma tan phi, but later on we are seeing that CL strength equal to C dash plus sigma dash tan phi dash, because we are considering the effective, because the earlier whatever the construction taken place on the total stress approach, those construction get damaged afterward, that the modified Mohr Coulomb theory get evolved in a better manner, and those principles say that as water table get rises, suppose in a condition water table rise up to the ground surface, the effective stress get reduced almost by half, nearly half. So that one of the most important concern for the geotechnical engineers and the civil engineers. That's why the interpretation of the pore water pressure is very much important. Okay, see, so the pore water pressure measured during the triaxial test can help in determining the nature of the soil, its response to the stress. Positive pore water pressure indicates that the soil is in a undrained condition, while the negative pore water pressure suggests that in the drained condition. The positive pore water pressure, negative pore water pressure also you read during the second chapter of the geotechnical engineering course 1. And by analyzing the pore water pressure, the engineer can classify the soil as either the normally consolidated or the over consolidated. Yeah, and what we mean by normally consolidated and over consolidated? As you are aware about the over consolidation ratio, we say that the stress applied in the past, it is the ratio of the stress applied in the past to the stress applied in the present. There is a small question. I will say you that whether the soil, normally consolidated soil is good or the over consolidated soil is good for the construction. When we say is at a specific soil side the over consolidation ratio is greater than 1, so that soil is good, or over it is normally consolidated like the OCR is 1. So I will tell you only that when the OCR is greater than 1, that soil is more suitable because it already experienced the amount of stress previously more than which are applied at the present. So that soil is very much compacted and in the good condition for any construction activity over there. See, okay, now we again say that developing the molecular failure envelope is what thing that the result obtained from the triaxial test can be used to develop the molecular failure envelope, right? You have seen in the starting when I am showing the recap of the last session, you see over there we have seen that the value of sigma 3 is found, and by varying the sigma 3 and sigma 1. Okay. By varying the value of sigma 3, the sigma 1 value also got changed. And then by drawing a common tangent passing through those Mohr circle, the Mohr Coulomb failure envelope is formed. And by plotting that, when the intercept on the tau axis is found, is said to be cohesion, and the phi is the angle of internal friction, which is the angle made by the horizontal axis with the intercept of the Mohr Coulomb failure envelope. Right. When we talk about the economic consideration, we say that it is most important to consider the economic aspects of the geotechnical engineering projects. The process of filling and compacting soil involves significant cost, as it requires the excavation, crushing, and compaction of soil material. Yes, so that cost also need to be understood. That cost also need to be taken care of during our any construction activity, any testing. We try to justify those things. So, and therefore, the engineers must carefully analyze the result and optimize the construction process to ensure the cost effectiveness and minimize the potential risk. Right. See, when we talk about the economic aspects of material, and the material worthiness means by how much that material is useful, worthful for the specific site. We say we introduce economic in engineering. When we say it's very much important because there are too much wastage, and this also sometimes lead to the increase of the overall project cost in one way or the other. So the economic consideration in the soil related project due to the material processing, as you know, that if we say that a specific soil has a less strength and that cannot bear that much amount of load which is going to be acted over there. So there are the two main perspective. One thing that we replace the soil over there from the another soil from the another side. So that is the most cost consuming because the transportation cost is there, and the material cost like soil cost is there, which we need to access from the other sides, and third is its availability. Another option is what? The best option is to replace, but whether that amount of soil we have, is there any place that is of no use from where we can take the soil and fill at the other place? That's not the case in the physical significance. So another thing is the soil improvement. That is also a course in itself. So we apply some ground improvement techniques. So that things are very much costly in at some places, because it is not only the mechanical mixing, some chemical things are there, sometimes some other things like some columns need to be created, or many more things are there. So we need to understand those aspects as well. So highlighting the process of consulting as a, it is like the people in the forensics takes their work seriously, that they see that what fingerprints is there. Or similarly, we civil engineers, geotechnical engineers are that much expert for the soil property and concerning its behavior in the field. Okay, so we will recap this section. So we understand the tri-axle test result is a critical aspect of the geotechnical engineering, and we also understand the one of the most important thing, that the pore water pressure and the development of more Coulomb envelope, and considering the economic factors, engineers can make the informed decision regarding the suitability and stability of the soil, the various construction projects. Okay, give me a minute. As I see, I haven't received any mail regarding the questions some of you are asking sometime before. So, if you want to answer those questions during this class only, please send me before 3:50 or 3 about 3:50, so I can go through those questions during a 5 minute break over there. Otherwise, I will solve those questions in the next class, and I will request any one of you send the assignment questions right away on the given mail, which is written in the chat box, and I also pin that chat. Okay. See, so now we are going to see the connecting material property. So the significance of the pore water pressure is there. They are like the building upon the concept of the pore water pressure to speculate the soil nature, and translating to the another class of problem center on the compacted phase. Now you see the compaction and the soil characterization, the reflection on the methods like the balance and replacement and the core cutter. As you are aware about the core cutter method, in which by which we are able to find the dry density, in this test the optimum moisture content, we are able the moisture content of the soil is also we are able to find. How the core cutter method is performed, you must be aware. If not, I will say you quickly. In the core cutter method, first of all, we take the equipment like the hammer and the core cutter equipments. We take it to the field. We clean a place over there. We want to perform the test. After which, the collar is placed over the core cutter core cutter cylindrical sample, and then the hammer is applied from the upward direction. The core cutter get inserted into the soil. Afterwards, we evacuate that the core cutter by removing the soil around it without disturbing the soil sample within it. And after that, we will determine the moisture content by taking the sum of the soil sample from interior, and the moisture content is found, as we also aware about it, weight with the soil in the core cutter is the bulk density, as its volume is also known, as its length and its diameter is also known, always also known to us. So we found the bulk density, and after the getting the moisture content, we amplify the relation like the gamma D equal to gamma B by 1 plus W, where the gamma D the dry density, gamma B the bulk density, and W is the water content. So with the help of that, we are able to find the dry density. And so in the sand replacement method, first of all, the calibration is taken place in the lab itself. Afterwards, we take the equipment to the field over there. And you can go through these two tests if you are not aware and you have not the first hand experience. Try to perform in your laboratory. If not possible, you can go across the YouTube over there. There is a NCTEL in YouTube channel over there. the peoples from the IITs and NITs are perform those tests and show you the physical demonstration. Okay, we also understand we also find OMC and the compaction curve with the help of the above test which are mentioned here. And the deformation characteristics is also known to us, like the understanding the relationship between the deformation and the stress on the dry and the wet side of optimum. As you see, when we perform those tests, you know now that as if the compaction effort increases, the value of dry density get increases and the optimum moisture content decreases. So those consideration is also understood with the help of this test. And a holistic approach could be developed by involving the particle size distribution. As you are aware, first of all, when you have gone to the soil laboratory, you have did the particle size distribution. And afterwards the different limits like liquid limit, plastic limit, those things at different interval limits you have performed. Then you have performed the dry density test like the core cutters and replacement. Okay, see, right, right. So we could able to develop a holistic approach. We could involve in the particle size distributions, compaction curve, compressibility, and the tri-axis tests. See, okay. So now you see a case study and the CSTN parameter. So you consider example a test result where the sigma 3 value is the 150 and 450 and the sigma 1 value is 400 and 1000 along with the corresponding pore water pressure. So for that we could find phi CU, and phi dash and C dash using the effective stress principle. Okay, so these are the questions, but whether everything is not mentioned over here, so leave it. We will not going to cover this over here. In the last 15 problems, these questions are again repeated. Over there, I will explain. See, so over here, the soil comparison to the shear strength analysis exemplifies the intricate layers of geotechnical engineering by skillfully combining the laboratory test and the field knowledge. The engineers unlock insight crucial for the safe and efficient execution of the soil related projects. Now we are going to decode the soil behavior through the shear strength analysis, a deep dive in the soft clay. See, so first of all, we start with the introduction for this section. So give me a minute. Okay. Now see, in a geotechnical engineering, we explore the dynamic relationship between the compaction, shear strength, and the pore water pressure in the soft clay. Uh, Over here, we understand that how the undrained test, specifically CU test, reveal the crucial information about the soil behavior. When we say the CU test, the consolidated undrained test, in this the in this test we are going to understand these things like the long term and short term stability. When we say the long term and short term stability, we consider about the test how much time is going to take place, like in the trial test also we say CD test, which takes place very quickly as compared to because when we say CD test, the consolidated drain test, the water is allowed to flow out during the both stages. In the stage one, that is the confining stage. In the stage two, that is the diabetic stage. In both the stages, the water is allowed to flow out. So, in that case, it is found that we are able to we are able to replicate that things in the sand types of soil. The soil is has the property of sand is replicating that relation, but when the clay soil is there, the water takes too much time to flow out. So over there, UU test is the most suitable. And we also understand that when the as per our requirement, we amplify the C and phi value in our relation sigma 1 equal to sigma 3 times for 45 plus 5 by 2 plus 2 secant 45 plus 5 by 2. That is also given to you during the fourth lecture. Okay, so the when we talk about the nature, the material nature, so it was so the dual nature of material, cohesive and frictional, and its implication. So it is always believes it is not like only cohesive soil or only sandy soil. The soil should be C5 soil. Soil must have some cohesion, might have some cohesion and might have some angle of internal friction, which implify in the soil property at any specific site. So you need to understand those things as well when we say a problem in which a U test conducted on a soft clay sample prompting about its nature and its necessity for the triaxial testing. So over here in a test method like the unconsolidated undrained U test using a Vance year test setup is take place because we know in a Vance year test is performed on a soft soil. Over there a torque is applied and that is said to be T, and the relation T by pi d square into H by 2 plus D by 6, where H is the height, D is the dia of that spring, and H is height of the section which is impacted in the soil. That is also one way and two way, that over there H by 2 plus D by 6 and the H plus D by 12 relations are there. Okay, now we see when we talk about the Mohr circle and its envelope, so creating Mohr circle for the three specimen and establishing a unique Mohr circle envelope for the soft clay and analyze the stress condition and their relevance for the problem, like identify a soft clay as an NC like the normal consolidated material and deriving the parameter phi equal to 0 and c dash equal to 0. After that, establishing the Mohr Coulomb failure envelope, and the envelope is formed. So the sigma 1 sigma 3 is also known for the different specific sections by which we are drawing the tangent to form the Mohr Coulomb failure envelope. As we see, the comprehensive a failure condition to the pore water pressure is also formed. Okay. Uh, Okay. See, so over here we understand that the intricate process of revealing the soil behavior in the soft clay through the undrained test and the continuous material properties test condition and the laboratory method under the problems for the required geotechnical engineering analysis. Something over there is written is wrong as well. So I will clarify during sending the presentation file to you. Okay, so for here I will take a 5 minute break and then after that we will start again. So please be here. We will take a 5 minute break before going to next session. Okay, we will start around 4.
यांचा नंबर नाही माझ्याकडे तुम्ही आता बोलू शकता का कोण
अहो तुम्ही ते कट केलं ना बरं का 600 कट केलं तुम्ही 600 बरोबर ना किती कट केलं नाही शिकवलं
त्या अकाउंट द्यायचं नव्हतं केलं ना खायचे 200 प्लेटचं
ते केलं ऍड केलं
200 प्लेट
अरे तर झाले होतं
Okay. Welcome back, everyone. I will start from here. Screen is not moving out. Right. Okay. Right. Okay. So we are on the, moving ahead. Moving ahead, and we are talking about in the geotechnical engineering, tri-axle testing serves a powerful tool to decode the soil behavior under the various conditions. In this presentation, we will talk about the back pressure during the tri-axle test and its role in simulating the real-world stress condition and the insight it provides into the soil stability. We also understand the really also understand the things behind selecting the specific sigma 3 value for the tri-cell test to replicate the real world stress condition, establish the connection between the soil depth, unit weight, and the effective stress to simulate the field stress condition with accuracy. The role of back pressure is very much important as it is a concept of applying the back pressure during the triaxial test to prevent the sample from collapse and signify the real life condition in as there in the field. And the back pressure, in addition to the pore water pressure, is preserving the physical integrity of the sample. As you are aware about the Skempton parameter A and B. In the Skempton parameter, we talk about sigma and the B and A and B are there. So B is the delta U by delta sigma 3. And A is a bar equal to AB and A bar equal to change in port water pressure during the deviating stress condition. And by interrelating those two, we are able to find the delta UD. So that is the thing over there. As when we talk about the significance, the when the value of B is Skempton pore water parameter value B is one, we say that the condition of the saturated condition is achieved, and and exploring the limitation of the traditional triaxial testing for the unsaturated soils and needed for the back pressure to ensure the saturated condition we perform. As you are maybe aware or seen the triaxial apparatus, and the demonstrated figure is also seen during the last class over there. I will again show you over here as well. Give me a minute. Over here you can see that the pore water pressure, self pressure, back pressure, everything is demonstrated over here. So we are talking about these things only over there as well. Okay, and the schematic diagram is seen by you. Now I will move ahead. Okay, so the limitation and of the traditional triaxial testing for the saturated soil and the need for the back pressure to ensure the saturated condition is now possible in the modern setups, and the technique of using the back pressure to saturate the unsaturated soil sample and making them suitable for conventional testing. When we talk about the different phases which are involved in the testings, first of all is the sample consolidation and undrained testing. So in this phase, the undrained condition and its importance of the pore water pressure development is taken care of. Afterward, the back pressure is implemented, in which we explore how the back pressure is introduced during the undrained test to simulate the saturated conditions. Then the sample consolidation and undrained testing takes place, in which they discuss the consolidation phase, undrained condition, and the importance of the pore water pressure development. Afterwards, the implementation of the back pressure takes place, in which exploring how the back pressure is introduced during the undrained test to simulate the saturated soil conditions. In when we talk about the stress path, and in the stress path and the soil response, the stress path and the Mohr column envelope, revisiting the stress path, as you are aware about the PQ curve, in which P is sigma 1 plus sigma 3 by 2 and Q is sigma 1 minus sigma 3 by 2, right? I think so, right? Okay, so the stress path is plotted in that way only. And when we talk about, as we go to the stress path, we understand the regulation of the shear strength. As we talk about its applications, the stress path concept to the practical scenario, like the in the basement construction and excavation, as you see that we have able to, hello, am I audible? Yes, right. Okay. So we are talking about the geotechnical applications of applying the stress path concept, the practical scenario like the basement construction and excavations are over there. When we talk about some more scenario like the complex geotechnical challenges, so the three scenarios are there, like the foundation construction, embankment building, and some new construction in the neighborhood of the existing condition to highlight the versatility of the triaxial testing. Simulating the real life situation, exploring how the triaxial testing mimics the complex stress challenges, changes, and reveals the soil stability insights. When we talk about the Stumpton parameter B, we say that recapping the two components of the pore water pressure U consolidation and U1 and U2. So to define the B parameter as the ratio of the pore water pressure change to the effective stress change, that is the delta U by delta sigma 3. And when we conclude this section, we say that in a triaxial testing, the augmented by the concept of the back pressure and concept of the back pressure um, emerges as a robust technique to mirror the natural stress condition and uh, unravel soil behavior intensive by manipulating the stress and preserving the sample integrity. The geotechnical engineers gain profound insight into the stability and the behavior of the soil material, paving the way for the safer and the more reliable construction practices. When we talk about the soil behavior through the triaxial testing, in the triaxial testing in geotechnical engineering plays a crucial role in unveiling the intricate behavior of the soil material under the varying stress condition. In this presentation, a series of triaxial testing scenarios exploring the roles of the parameter like the back pressure A and B factor, which are the Skempton parameters, and its significance in the characterizing the soil response is taken care of, and those things are discussed to replicate the knowledge about the things. When we try to understand the back pressure, we say that in a real stress condition, sigma 3 is selected to a depth and the unit weight for the accuracy of the minor field stresses, and exploring how the back pressure prevents the sample to collapse and maintains its physical health. Afterward, discuss the techniques of applying the back pressure to transform the unsaturated soils into the saturated states. Then we talk about the factor A and the factor B. So in first of all, the A is the delta U by delta sigma 1 minus sigma 3. As I say, the change in pore water pressure by the change in the stresses in the deviatric section, whereas B is the delta U by delta sigma 3, where A dash is equal to A into B. So the soil saturation indicator highlights the significance of B factor in indicating the soil saturation, and the threshold for the unsaturated condition as the value of B is 1, the soil is said to be in the saturated condition, and the value of B is 0, which is said to be in the unsaturated condition. When we talk about the significance of A, it's a parameter that characterizes the pore water pressure due to the shearing process as it is takes place during the shearing condition in the deviatric stress condition. When we talk about the derivation of the Skempton equation, we say presenting the Skempton equations linking delta U, delta sigma 1, delta sigma 3, A dash and B. So demonstrating that B equal to 1 characterizes the saturated sample as I have said earlier, and analyzing how the parameter A represents the pore water pressure changes due to the shearing, and the difference between the over concentration and normal concentrated soil material, explaining the over concentrated and normal concentrated transition and its instability implementation, showing how the shear strength is inversely related to the void ratio. When we talk about a tri-axle testing scenario, so evaluating a factor as a function of over consolidation ratio and its significance for designers, as it is very much important during the test as well whether the soil is in the saturated state or not, or whether it is in the unsaturated state. It is signified with the help of this content parameter only, and the stressing the importance of the cross checking result with the material property, the stress range, and the project objectives, exploring the different tests, discussing the five types of tri-axle testing problems, and providing the insight into interpretation of the results. When we recap this section, we say that the tri-axial test stand as a constant in the geotechnical engineering, offering a profound understanding of the soil behavior under the different stress scenario by comprehensively analyzing the parameters like the back pressure, A and the B factor, and the characterizing the soil. Represent the engineers can make informed decisions that contribute to the safer and the more reliable construction. Right? Now understanding the pore water pressure parameter in the triaxial testing. Okay. So first of all, we start with the introduction, in which the presentation focus on the comprehending the pore water pressure parameter in the tri-axial testing discussed here, and determination and the implementation understand these parameters is essential for the both academic as well as the practical implementation by the design engineers. When we talk about the pore water pressure parameter hold the practical significance in the geotechnical engineering and striving to present a balanced perspective for the better understanding as explaining the isotropic loading as a stress applied to uniformly from all directions like the sigma 1, sigma 2, sigma 3 and the Skempton equation relating the Skempton equation delta U equal to delta U1 plus delta U2 to the isotropic loading to the delta and the delta sigma 3 B parameter defining the B parameter as delta U1 by delta sigma 3 and its role in characterizing the soil mass. B parameter formula B equal to 1 by 1 plus CB by CC where CB is the fluid compressibility and CC is the soil scale and compressibility. The A parameter, when we talk about the uniaxial loading, A parameter introduce A parameter in a uniaxial loading at delta sigma 1 where delta sigma 3 is constant and the effect of shearing explaining how the delta sigma 1 minus delta sigma 3 due to the shearing cause the pore water pressure changes, defining A as A dash as A into B where A is the pore water pressure parameter due to the shearing and B is the saturation factor which is 0 for the unsaturated soil, 1 for the saturated soil. When we formulate the total pore water pressure, when we deriving the equation U equal to B into delta sigma 3 plus A into delta sigma 1 minus delta sigma 3 and it's simplified form utilizing a parameter providing the flexibility in using a parameter depending on the soil condition and testing objectives. When we talk about these applications, we will see the problems at the last regarding the same. When we talk about the role of the B saturation sample, exploring B equal to 1 as a saturated sample and its implementation in the soil saturation. When we simplified a parameter deriving A as a delta U minus delta sigma 3 by delta sigma 1 minus delta sigma 3 for the saturated soil sample. And when we talk about the conventional tri-cell testing describing the process of fixing the sigma 3 during the consolidation and its effect on a parameter. When we talk about determining the delta sigma 1, explaining how the change in the sigma 1 determined using the load cells for proving ring. When we recap this section, we say that the pore water pressure parameter B and A hold a valuable insight into the soil behavior under the different loading condition, understanding their derivations, application, and significance in the various scenario. Equips geotechnical engineer with the essential tool for the accurate interpretations and the informed decision making in the field. Right? Right. Now we are going to explore the pore water pressure parameter through the practical examples. So what are the examples we are going through? We will see over here. Okay. Okay. As we talk about the Skempton parameter B and A, we come to know across B as a Skempton parameter over there. With the help of that, we are able to found that in the tri-cell testing whether the sample is saturated or unsaturated. Similarly, with the help of A, as well we reveal the situation in during the derivative stress condition. So before formulating the sample, first of all, in the laboratory as well, when we go across to form our sample, we see that first of all we make to stand our sample in the confining stage. So we have to understand that at what time the stress need to be applied is from the vertical direction in order to achieve that much stress over there the failure takes place in the deviatory condition so that the sigma 1 sigma 3 would be found to form a Mohr circle in Vela. Okay, so in this presentation, we initiates of the pore water pressure parameter through the problem solving and the analysis includes the implication cases of the compactions on the pore water pressure, the relationship between the strain and the stress, and the significance of A and B parameters. Right. And when we talk about its significance on compaction, we say that how compaction impact the pore water pressure, how the capillary actions, compaction cost, and the pore water pressure works out. And when we talk about the okay, this is not the thing. Okay, how we calculate the parameters? We say that A parameter is defining A dash as A into B and its significance. So A parameter, so A equal to delta U minus delta sigma 3 by delta sigma 1 minus delta sigma 3 equation. And when we talk about the material characterizations, it's highlight the role of the tri-axial testing in understanding the soil behavior and shearing process. Now we analyze the pore water pressure parameter and the shear strength of soil. So before we go ahead, we will go with the questions which I put you out over here for you. So you will go across with those problems before moving ahead. Okay. See. Okay. So I will take a pen as well. See. So we are going with the questions that will make you understand the things which we are studying, that how we are solving the problems related to things which we are taking over here. Okay, see, first of all, what is the first question? First question is simple true and false question, and these are the most standard questions which are whether asked in the GATE examination or the civil engineering services examination. So first question is right, true or false. This is a true for problem. So first of all, the question says that if the Mohr circle, if the Mohr circle for a given state of stress lie entirely below the Mohr circle envelope of a soil, then the soil will be unstable for the that state of stress, whether it is true or false. So one can easily say that this statement is false only because okay. So this is so the answer for this problem is false. Why? Okay, I say answer is false. Why? Because as you know that when we form a Mohr circle in Vela, if a Mohr circle question is that if a Mohr circle for a given state of stress lies entirely below the Mohr envelope for the soil will be unstable for that state of stress. This is not the case because if this is one circle and this is another circle and state of stress lies over here. Okay, so at this point as this is sigma 3, this is sigma 1, this is sigma 3 dash, and over here sigma 1 dash, right? Okay, so this is the failure envelope, and if at any point if a stress is at this position, the Mohr envelope, if the Mohr circle of a given state of stress lies entirely below the Mohr envelope of the soil, then soil will be unstable. Unstable is a word which is false. If it is stable, if it is stable, then it is there is a no problem. But over here it is written unstable, so there is a if it is stable, then it is going to be true. But as it is mentioned unstable, so when the state of stress below, so unstable is false. That's why our answer is false. Explanation is also mentioned over here. If a Mohr circle for a given state of stress lies entirely below the Mohr circle envelope of the soil, then the soil will be in the stable for that state of stress, right? So this is the first and very basic problem. Now we move to our next problem. Over here it say that a unconfined compression test yield a strength of 0.1 Newton per mm square if the failure plane is inclined at 50 degree to the envelope to the horizontal. What are the value of the shear strength parameter? So it's asking about value of C is going to be what and what is the value of phi for the given condition. Right? I think so. This thing is understand. So unconfined compression test yield strength. So this is the shear strength S and it is asking about C and phi. So over here you see the unconfined compression test is there. So see value of sigma 3 is 0 and shear strength equal S equal to 2C tan 45 S equal to C plus sigma 3 tan 40 2C tan 45 plus 5 by 2 sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2C tan 45 plus 5 by 2 right. As it is mentioned, theta C equal to 50 degree. This is nothing but 45 plus 5 by 2. So over here, the 50 degree is 45 plus 5 by 2. 45 plus 5 by 2. 50 equals. As we know, our interrelation sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 45 plus 5 by 2 plus 2C tan 45 plus 5 by 2. I have said this many times. Okay, right? So over here, the value of sigma 3 is 0. Value of sigma 3 is 0. So sigma 1 equal to 2C tan 45 plus 5 by 2 and tan 45 plus 5 by 2 is nothing but 50 degree. So sigma 1 equal to 2C tan 50, right? So the value of phi should also be known. So by solving this, we this imply 45 minus 50 minus 45. So phi equal to 10. Now we need to find the C only. As phi is known, sigma 1 is known. So you can able to find C as 0.0419 and phi as 10 degree, which we are already found in our previous section. Okay, right? Right. So our shear strength parameter C and phi are found. Okay. So this is the question over here. Now we move to our next problem. Next problem say that the unconfined compression test the clay fail in the range. Okay, what is the question? Compression test of a stiff clay face in the range of 50 kilonewton per meter square, 50 to 100, 100 to 200 or above 200. So over here the answer is going to be 100 to 200 uh, kilonewton per meter square as it is standard value, right? Okay. Now we move to our next problem. So over here the two problems are mentioned here. The first problem states that what is the shear strength in term of the effective stress on a plane with a saturated soil mass at a point where the total normal stress like the sigma n is 295 kPa and the pore water pressure is 120 kPa and the effective stress and shear strength parameter C dash and phi dash is this. So what is the shear strength? Normal stress is 295 and pore water pressure is 120. So S equal to C plus sigma n tan phi. So sigma n is going to be 295 minus 120, right? Okay. So where is the pen? H S equal to the solution is already mentioned on the next page, but for the understanding, S equal to C plus sigma n tan phi. H value is mentioned C dash, phi dash, to sigma n dash, that is the effective. So sigma n dash is going to be 250, 295 minus 120, 295 minus 120, right? So you are able to find this, right? And you are able to find, you already know the value of C dash and phi dash, so you are able to find the value of S. Okay, so over here you see the sigma n value is there, U value is there, C value is there, and phi value is there. First of all, sigma n bar is found at 175. Then S equal to C plus sigma n tan phi, which written that is same thing, tau equal to C plus sigma n bar tan phi. When we solve, the solution is found to be 113, and we are moving ahead with that, right? Right. Now we are moving to the next question. Next question say that in a drain triaxial test, compression test, a saturated specimen of a cohesionless soil. Cohesionless soil means C is 0. Cohesionless sand fails under the deviatric stress of 3. Okay. So sigma 1 minus sigma 3. Deviatric stress is nothing but sigma 1 minus sigma 3. I have said very many times. And fail under the deviatric stress of 3 kg per cm square. I write only 3. You need to understand kgf per centimeter square. Then the cell pressure is 1 kgf per centimeter square. That is sigma 3. Right. And the effective angle of shearing resistance of the sand is about they are asking. So we will solve sigma 1 equal to sigma 3 tan square 45 plus 5 by 2, right? Okay, so from here, when we use the value of sigma 3 as 1, value of sigma 1 as 4, from here, and when we solve that, we are able to find the value of pi, and see over here, the sigma 3 value, sigma 1 minus sigma 3 is there, sigma 1 is known as 4, sigma 3 is already known as 1, and when we solve, we are able to find the value of first of all alpha. Basically 45 plus 5 by 2 is said to be alpha, and after that we are able to find the value of pi at 37 degree, and so our answer is going to be 37 degree, right? I think so. There is no problem over here. I think so. So we will move to the our next problem. So next problem states that if the effective shear strength parameter of a soil C dash phi dash as and 10 and 30. So first of all underline that C dash as 10, phi dash as 30. The shear strength on a plane with the saturated soil mass at a point where the total normal stress is 300 and the pore water pressure is 150. So this is similar to the previous problem. So I will not solve it over here because I have to write the same equation. I will directly go to solution and I will explain from there only. So see. Over here, the tau equal to C plus sigma n tan phi. As C is already mentioned 10 and sigma n is nothing but, okay, I will write sigma n is nothing but 300 minus 150. As the total normal stress sigma total is 300, right? U pore water pressure is 150. So sigma dash or sigma n bar, whatever you say, sigma n dash or sigma dash or sigma n bar is nothing but 300 minus 150, right? That is equal to 150. And this value of sigma n, this value of 150 is used over here, and the value of C is already mentioned as 10 and phi is already mentioned as 30 degrees. So we are able to find our answer as 96.6 kPa, right? So we will move to our next problem. So in the next problem state that in a triaxial test, excuse me, okay. The question is that in a triaxial test carried out on a cohesionless soil sample with a cell pressure of 20 kPa, whenever it is written cell pressure, it is nothing but sigma 3. Sigma 3 is mentioned as 20, right? And the observed value of the applied stress at the point of failure is 40 kPa. Applied stress at the point of failure, so that is the deviatric stress. That is sigma 1 minus sigma 3 h 40. So sigma D, that is nothing but sigma 1 minus sigma 3, is given as 40. Okay. So we are known sigma 3 is 20. So sigma 1 is going to be 60. 40 plus 20. ठीक है. Okay. So they are asking about the angle of internal friction of the soil carried out on the cohesionless soil. So cohesionless soil means C is equal to 0. Now we apply our main equation, basic equation. So we say sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 tan square 45 plus 5 by 2, and we are able to find the value of phi for this case. Sigma 1 is already known, right? That is 60. Sigma 3 is already known, that is 20, and 45 5 plus 5 by 2. When we apply, we get our answer as you see over here as 30 degree. So our answer is going to be 30 degree. Sigma 1 is nothing but 60. You can solve on calculator by yourself and you are able to get this answer. Sigma 3 is 20 and value of phi is understood, right? So our answer is 30 degree and which is solved over here. You are not keen to see this solution. Whatever I said, you go through that, you find the solution, you find the that answer only which I am using. Okay, right. Now we move to the next problem. Next problem state that a sample of a saturated cohesionless soil tested in a drained triaxial compression test showed an angle of internal friction as 30 degrees and deviating stress at the failure of sample at the confining pressure of 200 kPa is equal to, okay, this is one of also interesting problem. See, first of all, you say the sample of saturated cohesionless soil. First of all, cohesionless, so C equal to 0. Take the each word. Saturated is also word, but the cohesionless soil is more important for us. Treated in a drained condition, drained triaxial compression. Drained triaxial means water is allowed to flow out. Soon angle of internal friction as 30 degrees. Angle of internal friction as 30 degree means value of phi is 30 degree. Right? Right. And the deviatic stress at the failure of the sample at confining pressure of 200 kPa is equal to, it is asking sigma d is equal to what? Sigma d is equal to what? And the value of sigma 3 is also mentioned as 200. Okay, so we apply sigma 1 equal to, we apply this above equation, we apply sigma 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2 secant 45 plus 5 by 2. So C is already 0. So we say sigma 1 equal to sigma 3 means 200 tan square 45 plus 15. Right. Okay. Now I will take a calculator. Give me a minute. There is a calculator. Okay. I will take the calculator and do the calculation. So I will find 200. The value of sigma 1 is found to be 600. Right. So sigma d is equal to sigma 1 minus sigma 3. Sigma 1 minus sigma 3. And sigma 1 value is 600. So 600 minus sigma 3 is 200. So value of sigma d is going to be 400. So answer is going to be B. C. 400. Right? There is no problem over here. Now we move to our next problem. So next problem states that in a direct shear test is conducted on a uh, cohesionless soil C equal to 0. Again the cohesionless soil C equal to 0. You have to mark it down. Specimen cohesionless soil specimen under a normal stress. Sigma n is mentioned as 200 kilonewton per meter square. Specimen filled under the shear stress of 100 kilonewton per meter square. The angle of internal friction of soil in degree sigma n into 10 45 plus 5 by 2 plus C is equal to shear strength or tau, whatever you say. Okay, so over here the C is 0, right? So sigma and tan 45 plus 5 by 2. A direct shear test is conducted on the cohesionless soil specimen under the normal stress of 200. So 200 into tan 45 plus 5 by 2. When you solve on the calculator, what you found? 100. So phi is equal to, okay, I will solve. When I am solving it, I am found that minus 45 into 2 is nothing but 36.86. Okay. Sigma is equal to C plus sigma and tan phi. Oh, sorry. Sigma S equal to C plus sigma and tan phi. This is not the sigma. Eraser I needed. Okay. Phi equal to 26 degree. 26.56. So option A is the correct answer. Right? Over here you can also see. Now next question is that. Next question is that a soil is composed of solid spherical grains of identical specific gravity and the diameter is diameter between is 0.075 mm and 0.0075 mm with the terminal velocity of the largest particle falling through the water without flotation is 0.5 meter mm per second square. Then that for the smallest will be okay. So you see the largest particle is 0.075, right? And its velocity is 0.5. Smallest particle, right? Give me a minute. Okay, see. And smallest particle is nothing but 0.0075 mm. So over here you can see we have to find the velocity through this. So when we make our relation v1 into d1 square equal to v2 into d2 square as area into velocity is like v is proportional to d square. So from this when we solve we found the velocity at 2 will be nothing but the 0.005 mm per second. So you can use 0.005 mm per second. Option number A as a correct answer. Right? I think so. Over here, there will be no doubt in anyone's mind. We will move ahead. Now we will see our next problem. Yes, this is the problem related to vein shear test, and this is one of the most important problem because over here you see the diameter height. When I talk about now the interrelation t by pi d square into h by 2 plus d by 6. So this is related to that only. So question say a field means here testing instrument shown alongside with a inserted complexity in a deposit of a soft saturated silty clay. As we have known that this is applicable for the soft soil only. If the soil is hard, it is not possible to rotate it. So we are not able to find the strength with the help of this test. So this is the soft saturated silty clay with a vein rod vertical such that the top of the blades were 500 mm below. 500 mm below. Why this is important? Because if it is not below, the relation which we usually use it is not applicable. Okay. So upon the application of the rapidly increasing the torque about the vein of the rod, the soil found to fail when the torque reached to 4.6 Newton meter. This is nothing but torque T. Okay, I will write the relation as well. Assuming the mobilization of the undrained shear strength on all the failure surface to be uniform and the resistance of light on the surface of the vein rod to be negligible, what would be the peak undrained shear strength round up to the nearest integer? So over here, see the value of tau is going to be T T by pi d square into h by 2 plus d by 6. H by 2 plus d by 6. Right? Over here, T is nothing but 4.6. D is H is 100 mm and D is 50 mm. Okay. So when we solve this interrelation, we are able to found tau as, when we solve this relation T by pi T, when we solve this relation, we are able to found the value as 10 kPa. Okay, let me solve one time. Allow me, give me a 2 minute. H is 100 mm. Okay, in kilopascal. So 10 kPa will be going to be our answer. Yes, right. So this is our going to be answer. When you solve, you found 10.04. Right. Units need to be considered. Okay, so we move to the next problem from here. We, as you see, for the set over here, the different relation are written. That's not to worry. The relation what I have written is the same thing as this. And when you take the common t by pi d square, when you take common h by 2 plus d by 6 will become, and you are able to find that strength tau or cu, whatever the thing is same in our relation. Okay. Now move to the next problem. Next problem state that the for a saturated cohesive soil, a triaxial test yields the angle of internal friction phi as 0. Phi as 0. The conducted test is CD test, CU test, UC test or UU test. So this is a very simple thing. Like for the clay soil, it is nothing but the UU test, because we know that that simplify the real field condition, because in the clay as well the water is not allowed to drawn out in the both the condition, because it takes the too much time to flow out the entire waters from there, right? Now we move to the next problem. Okay, so over here the question state that in the unconsolidated undrained triaxial test, it is observed that the increase in the cell pressure from 150 to 2 kPa, 250 kPa lead to 150 to 150 to 2 kPa lead to a pore pressure increase in 80 kPa. सेल प्रेशर की बात हो रही है. We are talking about the cell pressure. It is observed that the increase of 50 kPa in the deviatoric stress result in increase in the 25 kPa of the pore water pressure. Over here we are talking about the A bar. The value of a Skempton pore pressure parameter B. So B is equal to delta U by delta sigma 3. B is equal to delta U by delta sigma 3. Right? So delta U is over here 80 and delta sigma 3 is 250 minus 150, that is 100. Right? So our answer is going to be 0.8. I think so. There will be no doubt in that. So C is the correct answer. Again, we move ahead. Okay, see over here the solution is also there. Now we move on to our next problem. Next problem states that in a drained, first of all, drained triaxial compression test on a saturated clay has a effective shear strength parameter C dash as this and phi dash as this. Hmm. And the consolidated and drained triaxial test on the identical sample of the clay at a cell pressure of undrained triaxial test at a cell pressure of 200 kPa means sigma 3 undrained is there sigma 3 200 and developed a pool water pressure of 150 kPa. So U is 150 in the second condition, right? The deviatic stress in kPa. So there is no problem in that. They are asking about the deviatic stress in kPa. So we use relation sigma 1 minus sigma 3. Sorry, and we use the same relation sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Just we know the value of sigma 3 known to us. We found the sigma 1 and then we subtract sigma 1 minus sigma 3 and we are able to. So first of all you use sigma 3 dash as 200 minus 150 as 50 and then use the interrelation which we say as this where I have written. Okay, you see over here the relation is written sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 by 2. Sigma 3 is known. Sigma 3 is known. Okay, entire relation is also not written over here. Okay, I will. Okay, over here you see sigma 3. Sigma 3 is known. C is known, phi is known, only sigma 1 is need to be found. When sigma 1 is found, we subtract sigma 1 minus sigma 3 and we are able to find the value of the deviating stress in that stage. Okay, I will write the equation over here for your convenience. Okay, over here I will write everything so that there will no doubt. Sigma 1 equal to sigma 3, sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. 2c tan 45 plus 5 by 2. This is the most important relation, right? So over here we know value of sigma 3 dash h 50 and sigma 1 dash we are going to found sigma 1 dash is sigma 1 minus u, sigma 3 dash is sigma 200 minus 150, so 50 and tan square 45 plus 5 by 2 tan square 45 plus pi is 22 to 22 by 2 is 11 plus 2c 2 into cohesion is also there 15 into 10 45 plus 11 56. When we solve it, I will solve it again. Give me a minute. 15 10 46 plus 50 into 1056. Right. So you find sigma 1 dash h. There is a pen. Sigma 1 dash as 132.14. So sigma d is sigma 1 minus sigma 3. It is going to be some mistake is there. Sigma 1 is 154. 154. So 154 minus 50 is 100. Answer. Okay. Over here you see the same relation is used and the value of sigma 1 is found, the value of sigma 1 minus sigma 3 sigma d is found. So this is the answer. Right? We will go ahead and we have two more problems left. So first question is that a soil sample is subjected to a hydrostatic pressure sigma. Hydrostatic pressure means the pressure you apply from the all direction is equal. The Mohr circle at any point in the soil sample would be. So we know the Mohr circle, the radius of Mohr circle, the center of Mohr circle, everything is known. So you know that the sigma is applied. Hmm. So the Mohr circle, what type of Mohr circle is going to be formed? As sigma x and sigma y both are sigma, so the radius of Mohr circle is going to be 0. So a point Mohr circle is going to be formed like this, right? Right? As you see in the hydrostatic pressure act equally in the all directions, so the point Mohr circle is going to be formed. So circle of radius sigma no, circle of radius sigma no, a point Mohr circle at a distance sigma from the origin is going to be formed. So option C is correct. Now we move to our last problem of our day, that is given over here. Okay, so the question states that a consolidated undrained CO triaxial compression test is conducted on a normally consolidated clay at a confining pressure of 100 kPa. Confining pressure means sigma 3. Sigma 3 is 100, right? And the deviating stress at failure is 80, means sigma d is 80. That is nothing but sigma 1 minus sigma 3. I have told many times. So sigma 1 is going to be sigma 1 minus sigma 3 is 80, sigma 3 is 80, so sigma 1 is going to be 180. Okay. Mm, deviating stress at failure is 80 kPa and pore water pressure measured at the failure is 50 kPa. Okay. Okay, so the effective angle of internal friction. So I will show you from the example only, from the solution only. I will erase it because some part of the question I have not read. Okay, so over here you can see the value of sigma 3 is 100, sigma d is 80, u is 50. So sigma 1 equal to sigma 3 plus sigma 3 plus sigma d as 180 and sigma 1 minus u and sigma 3 minus u is also mentioned. So we are able to find the value as you see the value of sigma u is 50, everything is mentioned over there. We are able to find the value of sigma 1 and after that sigma 1 bar is also known to you, sigma 3 bar is also known to you. We apply the interrelation sigma 3 1 equal to sigma 3 times square 45 plus 5 by 2 plus 2 c tan 45 by 2. We assume c equal to 0 and we are able to find the value of phi. That is going to be our answer. And with this, today's session I am going to sum up. And over here during this session, what we come to know that we understand the tri-cell test, we understand the problem related to the same, and all the process of UUCU and CD test we have understood it with a great extent. Now, one most important thing which I always give in the every class that the sum of the question, what is the shear strength? Try to write it by your own. Write the detailed procedure of the tri-excel test again. Perform the test if you are not already performed, or if it is not possible to perform those at the laboratory at your institute, or if you are a working professional, see the demonstration at list in the YouTube or at any other sections. Also, you can see the demonstration of the test, okay, right? And solve some problem. As I have shown you 16 problems, solve all these 16 problems by your own hand. And if the problem remains, you can ask me in the next class. And you can also consider some more problems from the given reference book over here or some other book which you have. And you can use those books to solve the problems, and that will help you in getting the better understanding of the subject. So with this, I will sum up the today's session. Thank you everyone for attending this session. We will meet again in the next class, and as you have mentioned the assignment problem, I will try to solve in the next class whatever the problem you have, and I will request all of you, please send me the mail regarding the same. As I have given you the email ID, or you can mention in the comment section of the YouTube as well. I will try to solve it out. So thank you everyone for attending the session. I wish you a very happy weekend. Thank you very much.